So picture this. A lawyer walks into federal court, right? And he's holding this brilliantly written legal brief.
Oh boy. I know where this is going.
Yeah, you know the story. So he argues his client's case perfectly, citing, I think it was 6 previous court decisions. And the judge, doing his job, asks to review those 6 cases.
Right.
The problem is they don't exist.
They do not.
The docket numbers, the judge's names, the rulings, all of it is completely fabricated. Because the lawyer didn't actually write the brief. He asked an artificial intelligence chatbot to do it for him.
Which is just a massive mistake.
Huge. The AI didn't know the law, obviously, but it knew exactly what a legal citation was, supposed to look like. So it just invented them. So today, for our deep dive, we're talking about why the most advanced technology on Earth is, well, kind of a compulsive liar.
It's a terrifying story, honestly. But it perfectly illustrates the central paradox that we are all living in right now. I mean, we are totally surrounded by algorithms.
Everywhere.
Exactly. Yeah. If you're listening to this on your morning commute, a GPS system is likely routing you around traffic by analyzing thousands of other drivers' cell phone speeds.
Right.
Your bank is using AI to monitor your credit card.
Right.
Yet the vast majority of us have a really fundamental misunderstanding of how the machine actually operates.
Yeah.
We treat it like this all-knowing oracle, which is exactly how that lawyer ended up in front of a very, very angry federal judge.
Yeah, and today we are dismantling that oracle. That's our mission for this deep dive. We're stepping away from the Hollywood sci-fi narratives and digging into the actual practical mechanics of artificial intelligence based on our sources today.
Yes.
We want to figure out how it predicts rather than thinks, why it hallucinates those confident lies, and how you can actually take control of it in your own life. Because, if you don't understand the tools shaping your reality, you essentially surrender your agency to them.
You really do. And a great way to start taking back that agency is to look at the core illusion of modern AI, particularly the large language models, or LLMs.
The stuff that powers the chatbots.
Exactly, the chatbots. The illusion is that when you type a prompt, there is a cognitive process happening on the other end. You ask a question, and it gives you this beautifully formatted, nuanced paragraph.
Right, it feels like a real conversation.
It does. It completely tricks our human brains into assuming there is comprehension happening.
So, okay, let's unpack this. What is actually happening? If I type, write a poem about a rainy day, and it instantly spits out something that sounds exactly like Robert Frost, what is the machine actually doing under the hood?
It's calculating probabilities.
Just math.
Just math.
Yeah.
To put it simply, it is an aggressively confident prediction engine. The AI doesn't read your prompt and understand the concept of rain or the emotion of sadness.
Okay.
Instead, it breaks your prompt down into what are called tokens.
Tokens.
Yeah, tokens. A token might be a whole word, or it might just be a chunk of a word. The system then takes those tokens and maps them mathematically in this massive multidimensional space.
Okay, I want to make sure I'm following this. Instead of seeing words with actual meaning, it basically just sees a mathematical map of relationships.
Precisely. Through its training on billions of pages of text, the AI has learned the statistical likelihood of certain tokens appearing next to other tokens.
Wow.
So it isn't writing a poem, right? It's predicting which word is mathematically most likely to come next based on the patterns it mapped during its training.
It's like an autocomplete.
Exactly like an autocomplete. It evaluates the context of your prompt and constructs a response one single token at a time, calculating the highest probability pathway.
But it's an autocomplete that can, pass the bar exam or write a fully functional block of software code.
Right.
I think the scale of that is what really throws people off. Like, we're used to autocomplete finishing our text messages, not writing a master's thesis.
Well, the scale is the magic trick, right? When an autocomplete system has billions of parameters.
Parameters meaning what, exactly?
Meaning billions of interconnected mathematical weights that dictate those probabilities.
Oh.
When it has that many, it can mimic human reasoning to just an astonishing degree.
Yeah, clearly.
But it is crucial to remember it is only pattern matching on the surface level.
Yeah.
It takes everything you say entirely at face value.
Which explains the bar exam thing.
Yeah.
It doesn't need to understand the law to pass.
Okay.
It just needs to have mapped the statistical relationships between legal concepts way better than a human can memorize a textbook.
That's exactly it.
But how does it build that map in the first place? Like, how do you train a machine to recognize those billions of relationships without manually programming every single rule of grammar and logic?
Well, you can't manually program it. The complexity is just way too high.
Right.
Instead, you have to let the machine learn the patterns itself. And data scientists generally use three main methods to do this. The first is supervised learning.
Supervised learn. Okay.
This is where you feed the AI a massive data set where absolutely everything is explicitly labeled.
So, like, if I want to teach it what a stop sign looks like, I just show it a million pictures of stop signs.
You show it a million pictures labeled stop sign, and crucially, a million pictures labeled not a stop sign.
Ah, okay.
But it's not just passively looking. The AI attempts to identify the stop sign, and its prediction is then compared to the actual label. If it's wrong, the system calculates the error rate, which is essentially how far off its prediction was.
Grading a test.
Yeah. And then it uses a mathematical process, often called backpropagation, to go back through its own internal network and adjust the mathematical weights.
It tweaks the dials.
It tweaks the dials.
Yeah.
So the next time it sees that image, the probability of guessing correctly is slightly higher.
So it's constantly refining its internal math until the error rate drops to near zero.
Exactly.
Okay, that makes sense when you have humans labeling the data. But what about unsupervised learning? Because I imagine we don't have enough humans on Earth to label every single piece of data on the internet.
We definitely don't. So unsupervised learning is where you take away the labels completely.
Just raw data.
Yeah, you hand the AI a massive, chaotic pile of raw data and essentially program it to find the inherent structures or hidden patterns on its own.
How does that actually work in practice, though? Like, if you're listening to this while driving to work, how does unsupervised learning affect your daily life?
Oh, the best example of this is banking fraud.
Really?
Yeah. Banks process millions of credit card transactions a minute. Humans can't manually label every new type of fraud because fraudsters literally change their tactics daily.
Right, it's a moving target.
So the bank uses an unsupervised learning algorithm. It feeds the AI all the raw transaction data, and the AI plots every transaction in a high-dimensional mathematical space based on variables like time, location, amount, purchase frequency, things like that.
So it's clustering the data.
Yes, most normal transactions group together in a dense cluster. But suddenly, there's a transaction that mathematically sits far outside that normal cluster. It's an anomaly.
Oh, I see.
The AI doesn't inherently know it's fraud. It just knows it statistically does not belong with the rest of your normal behavior.
Right.
So it flags it, and your card gets frozen. It finds connections and outliers that human analysts would just never spot.
That is incredibly powerful for data analysis. But there's a third method our sources talk about, which feels like, I don't know, the missing link for how these systems get so ruthlessly efficient at specific tasks?
Reinforcement learning.
Reinforcement learning, yes.
This is where things get really fascinating and honestly a bit risky. Reinforcement learning is learning through trial and error in pursuit of a very specific goal.
Okay.
The system is given an objective and a digital environment. When it takes an action that moves it closer to the goal, it gets a mathematical reward.
Like a positive adjustment to its score.
Exactly, a positive adjustment to its scoring function. And when it moves away from the goal, it gets a penalty.
Our sources use an analogy here that I really want to explore. They compare an AI trained this way to a highly trained working dog, like a search and rescue dog fetching a ball.
It's a great analogy.
Yeah, because the dog doesn't care about the big picture, right? It
Right.
just wants the reward of the game continuing. It will relentlessly pursue whatever scent it was trained on.
The analogy is super helpful for understanding the singular focus of the system. The algorithm is just trying to maximize its mathematical score. That is its only objective.
Right.
It will randomly try millions of different pathways, and whatever pathway yields the highest numerical reward gets reinforced.
Wow.
The machine doesn't care about the context of the task, the ethics of the task, the collateral damage. It only cares about the score.
But wait, how do you actually penalize a machine? I mean, it doesn't feel pain. What does a penalty actually look like in the code?
It's just a negative mathematical value added to its reward function. Feel a bit like a video game score.
Okay.
If you lose points every time your character touches the lava, you quickly learn to stop touching the lava to keep your high score.
Right. Makes sense.
The AI runs billions of simulated scenarios at light speed. Every time a pathway results in a negative score, the algorithm adjusts the internal weights of that specific pathway down, making it mathematically less likely to be chosen on the next iteration.
Okay, here's where it gets really interesting to me. If it's running billions of iterations, optimizing purely for a score, what happens when we accidentally give it the wrong target?
Oh, that's the big question.
Right. Like, if the AI is the dog blindly chasing the ball, what happens when we throw the ball off a cliff?
It will jump off the cliff to get the ball.
Really?
Absolutely. Because the reward function tells it that getting the ball is the only thing that matters. And this relentless, unthinking optimization leads us directly into AI's most dangerous flaws.
The confident lies.
Yes.
Mm.
If you optimize an LLM to always provide a helpful, complete-sounding answer to a user's prompt, it will do everything in its power to fulfill that objective.
Even if it has to invent reality to do it. Which brings us right back to the lawyer with the fake court cases.
Exactly, the hallucinations.
Ugh.
Or, like you said, what we should really call confident lies.
Yeah.
Because the AI wasn't trying to deceive the lawyer.
Right. Deception implies intent.
Exactly. The AI simply received a prompt asking for legal citations. It searched its probability map and generated a string of tokens that mathematically resembled a legal citation.
Wow.
It optimized for syntactic plausibility, not factual truth. It doesn't have an internal mechanism to distinguish between a real case from 1998 and a statistically likely string of words that sounds like a case from 1998.
It's just wild. So wait, if it just amplifies the mathematical realities of its training data, that means an AI trained on flawed human data will just inherently reflect those flaws.
Completely. And this is a massive issue when we move beyond text generation and look at algorithmic decision-making. Historically, people call this garbage in, garbage out, but that's a bit too simple.
What's a better term?
A better term is the echo chamber effect.
Walk me through the echo chamber effect in a real-world scenario. Let's say corporate hiring.
Perfect example. Several years ago, a major tech company tried to build an AI tool to review resumes and find top engineering talent. They trained the AI on the resumes submitted to the company over the previous 10 years.
Okay.
The reward function was to find patterns that correlated with successful hires.
But the tech industry over the last 10 years has been heavily male-dominated.
Exactly. So the historical data show that the vast majority of successful engineers hired by this company were men.
Oh, I see where this is going.
Yeah. The AI, acting as a pure statistical engine, mathematically assigned a higher positive weight to resumes containing male-associated keywords. It actually penalized resumes that included the word women's, as in, women's chess club captain.
Wow. So it mathematically weighted a demographic trait as a success factor.
Exactly.
It wasn't programmed to be prejudiced, right? It was just ruthlessly reflecting the statistical reality of the data it was fed.
It held up a digital mirror to the company's past biases and just automated them. The AI doesn't have the common sense to step back and say, wait, this data is skewed by societal factors. It just optimizes for the patterns it sees.
Okay, so if it's this prone to bias, and if it hallucinates court cases just to please the user, why on earth are we letting it anywhere near critical infrastructure?
That's a fair question.
The sources mention AI is being used in medicine to detect cancer and in space exploration. Why are we trusting a compulsive liar to diagnose a patient?
Well, because when constrained to incredibly specific non-generative tasks, the math is extraordinarily powerful.
Non-generative.
Right. AI in medicine isn't an LLM writing a creative story about a tumor. It is a specialized supervised learning model trained exclusively on millions of medical scans.
Oh, okay, that makes sense.
A human radiologist looking at a mammogram is limited by the biology of the human eye. We can only process so much contrast and pixel variation.
But the machine doesn't see an image, right? It just sees the underlying data.
It sees the microscopic mathematical variations in pixel density. It can flag an anomaly that might take 5 more years to become visible to the human eye.
That's amazing.
It is. And this is the critical dividing line. The AI does not make the diagnosis.
Right.
It acts as a hyper-advanced magnifying glass. It highlights the area, and the human doctor brings the context, the medical history, and the human judgment to make the final call.
So the human provides the oversight that the machine lacks.
Exactly.
How does that translate to something like space exploration, though? Because human oversight is physically delayed there. I mean, we have rovers on Mars. We can't joystick a rover in real time because it takes light, up to 20 minutes to travel between Earth and Mars?
Right, and that latency is exactly why AI is necessary there. A Mars rover uses a local AI navigation system. It analyzes the topological data from its cameras, again, not generating text, but classifying terrain data.
Right, crunching the math on the rocks.
Exactly. It calculates the probability of a rock causing a wheel slip or a slope being too steep. It processes the physics locally and decides on a safe path, preventing the rover from driving off a crater while waiting 20 minutes for a human to hit the brakes.
So it really is about the right tool for the right job.
Always.
A generative model for brainstorming, a classification model for terrain, a clustering model for fraud. But, okay, let's bring it back to the listener sitting at their desk trying to use a generative AI to summarize a report or write an email.
Sure.
How do they use this daily without crashing into a metaphorical cliff? We know it hallucinates. We know it just predicts tokens. How do we take control?
The absolute first rule is to stop treating it like a search engine.
Okay.
We've all been conditioned by Google. We type a query, we get a list of facts, we assume they are accurate, and we moved on. If you treat an AI chatbot that way, you will get burned.
Because the first answer it gives is just the most statistically obvious generic response.
It is a rough draft, always. Beginners accept the first output, which is why they get generic, sometimes wildly inaccurate results.
Right.
The secret to working with generative AI is constraining the prediction engine. You have to narrow the multidimensional space it operates in.
So how do you do that in practice?
Through highly specific, iterative prompting. If you say, explain the supply chain crisis, you are leaving the parameters wide open. It will pull from everywhere and give you a textbook summary.
Just a generic blur.
Yeah. Instead, you say, act as a logistics expert. Explain the current supply chain crisis focusing only on semiconductor manufacturing in Taiwan. Write it for an audience of high school students using a conversational tone in under 200 words.
Ah. You're building walls around the probability map. You're telling it, only pull tokens from this specific area and arrange them in this specific style.
Precisely. And if it misses the mark, you don't delete the chat and start over. You correct it.
Oh, really?
Yeah, you reply to it. You missed the point about shipping delays. Rewrite the second paragraph and emphasize the port closures. You guide the statistical path step by step.
Okay, so we should really treat AI like a highly capable, incredibly fast, but completely literal-minded intern.
That's the perfect way to look at it.
You wouldn't just publish an intern's first draft without reviewing it, right? You give them notes and make them do it again. But let me push back on this a little. Managing an intern takes a lot of time.
It does.
You have to review their work, send it back, check it again. If I have to constantly check the AI's work and rewrite my prompts to constrain it, isn't that kind of defeating the purpose of a time-saving tool?
It is a trade-off, definitely. But the time is saved in the iteration speed. You don't have to wait 3 days for the intern to rewrite the report. You wait 3 seconds.
Oh, that's a good point.
The bottleneck is no longer the generation of the text. The bottleneck is your ability to edit and refine. You transition from being the writer to being the director.
That is a massive shift in how we work. You have to be the one to decide when the work is done.
Yes.
Because the machine doesn't know what finished looks like. It only knows how to continue generating tokens. You have to provide the human judgment to say, this is accurate, this is useful, we are done.
You provide the grounding in reality. You catch the confident lies. You watch out for the echo chamber biases, and you apply the final product to the real world.
That makes so much sense. So to bring this all together for you listening, AI is a pattern prediction engine, not a thinking mind. It's processing mathematical weights and probabilities at a scale that mimics human thought, but it is entirely devoid of understanding.
It is unbelievably powerful for organizing massive amounts of data, for driving innovation in science, and for accelerating your daily workflows. But it's a tool that requires a skeptical, active operator.
We have to be the ones who hold the responsibility. We supply the judgment. And honestly, we are just scratching the surface of the underlying mechanics here. If you want a clear, practical way to use AI properly, the book, AI for Teenagers, second edition, is now available on Amazon.
It's an excellent resource for building the digital literacy required to navigate this landscape.
Yeah.
It really helps you move from being a passive consumer of this technology to an active director of it.
Definitely. Now, before we wrap up our deep dive today, there's one final thought I want to leave you with, something for you to mull over that builds on this idea of statistical prediction.
Oh, I like this one.
Right. So as these systems become more integrated into our personal devices, they are becoming hyper-personalized. They are constantly updating their probability maps based on your specific habits, your writing style, your preferences.
They're basically learning the mathematical weights of you.
Exactly. So imagine a near future where an AI system has learned to perfectly mimic your exact communication style. It writes your emails, your texts, your professional reports exactly as you would. It uses your specific slang, your pacing, your humor. It becomes a perfect digital mirror.
It predicts what you would say with near-perfect accuracy.
So the question is this. At what point does the digital version of you become indistinguishable from the real you to the outside world?
That is wild to think about.
And if a machine can perfectly replicate your voice and your thoughts in the digital space, does the difference even matter anymore? Something to ponder the next time your phone auto-completes a text to your best friend and you hit send without changing a word. Just make sure you're still the one deciding the destination. We'll see you next time.